Good morning, everyone. Today we're going to get a little bit deeper into geometry, and we're actually going to start talking about shapes and the angles within those shapes and what those angles add up to. So I'm going to start a note sheet here. Everything that I put down, you should write down in your own notebook. I will try to keep this short and sweet. Along the way, you feel free to pause this video at any time to get caught up, or if you need to hear something over again, you can always rewind it. That's what's great about these videos, is you can access this material on your own. Okay, so today we're going to be talking about, make sure you get this title down. Today we're going to be talking about quadrilaterals and triangles. Now, a quadrilateral is a four-sided shape, and a triangle is a three-sided. An example of a quadrilateral would be a square. And the reason I'm starting with a square is because I want to show you guys what the angles are inside of a square. Now, a square has perpendicular lines, meaning that they all intersect at 90-degree angles. So 90 degrees, 90 degrees, 90 degrees, 90 degrees. That little box there represents 90 degrees. If I add up all of these 90 degrees angles, 90 plus 90 plus 90 plus 90, I'm going to end up with 360 degrees. So there's one of our first points right there is all angles, the sum of the angles within a quadrilateral is always 360 degrees. Now, it doesn't have to be a square. It can be a rectangle, or it can be a parallelogram as well. A parallelogram looks something like this. I think of it as a square that's kind of been squished down. And if you look at these angles, I no longer have 90 degrees anymore. They're no longer intersecting at 90 degrees. But they've been squished in a way where I have an acute angle here, an acute angle there, and an obtuse angle here, obtuse angle here. And even though that those angles have been squished and they've become obtuse and acute, they're still going to equal 360. Because if I straighten this thing back up, I'm going to get back up to a square. And we know, we've just established that 90 times 4, 90 plus 90 plus 90 plus 90 equals 360. So all quadrilaterals equal 360 degrees, all the angles inside of them. Okay, let's move on to a triangle. And let's think about a triangle as half of a square. So there's my square. And I can have a triangle fit perfectly inside of that square. And with that idea that a triangle is just half of a square, we can look back to, hey, how many degrees does a square have? 360. Well, what's half of 360? Half of 360 is 180 degrees. So there's our next rule when it comes to triangles. All of the angles inside of a triangle, let's say, call that on right. 1, 2, 3. They're always going to add up to 180 degrees. So those are our two big concepts here. Quadrilaterals add up to 360. Triangles add up to 180. Let's do a quick exercise around this idea of trying to solve for an unknown angle within a triangle. So here's a triangle. So I'm asking you to solve for the unknown angle. In this case, it's represented as x. So what we're going to do is set up an equation around the idea that all these angles add up to 180. So I'm going to take all of my angles, x, this angle, remember, is a right angle represented by the box, plus 90 plus 48 equals 180. So I'm going to say x plus 90 plus 48 equals 180. There's my equation to represent this situation. Again, we know all these angles equal 180. So now I'm just going to set up that equation and set them all equal to 180. The first thing to do when I'm solving for an x is I need to combine like terms. 90 and 48 are my like terms that add up to, we're going to say x plus 90 plus 48 is 138 equals 180. After I combine like terms, now I try to isolate that x by using SAB-MEG. I can do that by taking the constant away, taking this 138 away. So my 138's drop out. I'm left with x equals 180 minus 138 is 42. So my missing angle here is 42 degrees. And that's all I got for you.